You know, we use the word information all the time, like every single day. We get it, we share it, we look for it, we even fight over it. But have you ever actually stopped and asked yourself, what is it? It sounds like such a simple question, right? But as we're about to see, that one little question is a rabbit hole that leads to some of the deepest, most mind-blowing ideas in all of science and philosophy. So right out of the gate, we have a problem. And the problem is our own language. The way we talk about information is, well, kind of confused. We use the word in ways that totally contradict each other, and most of the time we don't even notice. So let's ask it point blank. What is information? Deep down, we all feel like we know what it is. But that gut feeling, that intuition, is actually pulling us in two completely different directions at the exact same time. Okay, check this out. Both of these sentences sound perfectly normal, right? In the first one, we talk about false information, makes total sense. But then look at the second one. If you're informed about something, it means you know a fact, something true. So, which one is it? Can information be false, or does it have to be true? The way we talk, the answer is somehow both.
So how do we untangle this mess? Well, we need to start at the very beginning. We need to draw a really clear line between information and its raw ingredient, which is data. Believe me, they are not the same thing, and figuring out the difference is the key to unlocking this whole puzzle.
So let's start with data. What is it? The best way to think about data is that it's just raw, unorganized stuff. It's context-free. So a number like 85, that's data. It's a fact for sure, but without any context, it's pretty much meaningless. 85 what? Percent on a test? Miles per hour? We have no idea. It's just a raw material waiting to be used.
And information, well, that's what happens when you take that raw data and you start to process it. You organize it, you give it structure, you put it into a meaningful context. Suddenly, it's not just a random collection of facts anymore. It's a group of facts that actually tells you something logical, something useful.
You've probably seen this idea visualized in something called the DIKW pyramid. Right there at the very bottom, the foundation of everything is raw data. But when you organize that data and give it context, you climb up to the next level, information. And for what we're talking about today, that first step up is the one that matters most.
This table really lays it all out. A single student's test score, that's data. But the average score for the entire class, now that's information. See the difference? It has context, it has meaning, and it's built from data. Without the data, you can't have the information. Okay, get ready, because we're about to take a hard left turn. For the next few minutes, I want you to forget everything about meaning and context. We're going to look at information from a completely different angle, as something you can actually measure mathematically. And it's all thanks to one incredibly brilliant engineer.
Back in 1948, this guy named Claude Shannon was working on a very practical problem: how to send messages over telegraph wires without them getting garbled. And to solve it, he had to do something radical. He decided to completely ignore the meaning of the messages. For Shannon, information had nothing to do with what a message said. It was all about one thing: how much uncertainty it got rid of. So let's put this idea to the test. According to Shannon's theory, how much information is there in the result of a single, simple coin flip?
The answer is exactly 1.
1 bit, to be precise. You've heard the word a million times. A bit is the fundamental unit of information. It's the smallest possible piece. It's the amount of information you need to decide between two equally possible choices: heads or tails, yes or no, 0 or 1. Before the coin flip, there are two possibilities. After, there's only one. That reduction of uncertainty is 1 bit of information.
Shannon's colleague Warren Weaver put it perfectly. Information isn't about what you say, it's about what you could have said. Think about it this way. A message that says, "The sun rose this morning," contains almost zero information. Why? Because it wasn't a surprise. You were already certain it was going to happen. But a message that correctly predicts all the lottery numbers, that contains a massive amount of information because it eliminated a huge number of other possibilities. It's all about surprise.
All right, so Shannon's theory is incredibly powerful for engineering and computing, but it doesn't help us with our original problem, does it? The whole true versus false thing. For that, we have to bring meaning back into the picture. And to do that, we need to turn to the world of philosophy.
A philosopher named Luciano Floridi came up with this really helpful 3-part test. He says that for something to count as information in the way we usually mean it, it has to pass 3 checks. First, it has to be made of data.
Second, that data has to be well-formed. It has to follow the rules like grammar and syntax. And third, that well-formed data has to actually be meaningful. So, dog bites man passes all three, but Jigo Staben in Ma fails step 2. And colorless green ideas sleep furiously, well, it's grammatically correct, but it fails step 3 because it's meaningless.
So, anything that passes those 3 tests gives us our first category: semantic information. This is just well-formed, meaningful data. And here's the crucial part: it can be true or false. A novel, a work of fiction, a political promise, even straight-up misinformation. It all counts as semantic information. And boom, right there, we've solved the false information part of our paradox.
But what about the other half? The feeling that to be informed means you know something real. For that, we need a stricter category. We need factual information. This takes semantic information and adds a tough 4th rule. The data must also be true. It has to correspond to reality. And this finally explains our intuition that real, useful information, the kind that lets you actually know something, has to be truthful.
Okay, we've seen information as organized data and as a way to measure uncertainty. But hold on, because there's a third, much deeper, and honestly much weirder idea that's been coming out of physics. It's the theory that information isn't just a tool we use to describe the universe, but that information is what the universe is actually made of.
The physicist Rolf Landauer said it as bluntly as possible: information is physical. What he meant is that information can't just exist as some abstract thought. It has to be written down on something real. It has to be stored as ink on a page, as a magnetic charge on a hard drive, or as a pattern of neurons firing in your brain. In other words, no information without physical representation.
And then, the legendary physicist John Archibald Wheeler took this idea to its mind-bending conclusion with 3 simple words: it from bit. This idea is absolutely staggering. He was suggesting that every particle, every planet, every physical thing in the universe gets its existence from bits. That if you drill down to the very bottom of reality, you don't find matter or energy, you find yes or no questions. You find information.
Now, this isn't just some philosophical hand-waving, it has real, measurable consequences. Physicists have shown that erasing even a single bit of information must generate a tiny specific amount of heat. The concept of entropy, the universe's tendency toward disorder, is now being reframed as missing information. It's leading some scientists to wonder if the laws of physics themselves aren't about forces and particles at all, but are actually just rules about how information is processed and transformed. And that leaves us with one final, truly profound thought to chew on. If the universe, at its most fundamental level, is just a giant cosmic computer processing information, then what are we? Are our thoughts, our consciousness, our entire lives just part of that cosmic computation? It's a question that starts with a simple word and ends at the very edge of what we know about reality itself.